right, let's talk. No name on it? Oh, it's something you need to turn in?
Yeah, I wasn't here today.
Okay, let's talk about surface area. You guys know what that means?
Yeah.
So, if you have a three-dimensional object, what's this called, by the way?
A
Rectangular
prism.
prism. Well, you have stuff inside, you have space inside the rectangular prism, and that space is measured by what we call volume. But sometimes you want to know how much space is covered just by the flat surfaces on the outside of the shape. And that would be called surface area. You guys remember the chapter we did called areas? Was it chapter 7 or something like that? I don't kind of forget. A couple chapters ago. So remember, area is just a measurement of how many square units fill a two-dimensional space. Like if this is a square inch and that's a square inch, if this was like say 7 inches by 4 inches, then the area of this rectangle is 28 square inches. That's how we label it. So three-dimensional objects also have areas if you just look at the outside of the shape. How could we find the surface area of this prism? Yeah, basically if you look at it, how many sides does this have? That what you said was wrong. That was wrong. It's got 6 sides. So we could, one way to do it, this is not the way we're going to do it. We could find the area of all 6 of these rectangles and add them together. That's basically what surface area is. So I have a box here. So this isn't quite a perfect rectangular prism, but it's basically the same thing. We could find the area of each of these sides and the bases, the top and the bottom. If we added all those together, that would be the surface area. Okay, that's the general idea. But there's kind of some tricks that you can do that are going to make it a little bit easier instead of just doing that. So that's just adding all of them together. Okay, one of the tricks for a prism is that the two bases are identical. The two bases of a prism are identical. So let's say this is an 8 by 6 rectangle on the bottom of this prism. What would the area of this base be? 8 times 6, 48. So if the base area is 48, we'll say inches or something, just make it up. Okay, let's say the height of this prism, kind of like a building, right? It's kind of like a high rise or something, stories. Let's say, I don't know, maybe about 12. We'll say 12. We'll say it's 12 inches. So 48 inches would be the area of this base, and it would be the area of this base. But what about the lateral faces, the up and down sides? You could do like 12 times 6 for the right side. The left side would match that. We could do 8 times 12 for the front, and the back would match that, and we could add them all together. Here's what we're going to do instead, though. We're going to do the perimeter of this base times the height of the prism. Okay? Imagine I took scissors and made a cut right here, and then unfolded this prism. What would it look like? It would look like a giant rectangle. And how long would the bottom of the rectangle be? This plus this plus this plus this. Okay, it would be the perimeter of the base. How tall would the rectangle be? 12 inches. It'd be this height right here. So all of these lateral faces, these up and down sides, we're going to do perimeter of the base times the height. Okay, So the perimeter of the base, 8 plus 8 plus 6 plus 6, or 8 times 2 plus 6 times 2, would be 16 plus 12 would be 28. So if you do the perimeter of the base times the height, this is 56 plus 280, 336. That would be the lateral area. That's how many square inches fit on the lateral surface. Okay, but we also have the two base areas. So 48 times 2, 96, and you add those together, and that would give you the total. What does that come out to? 432. This is an area, so it's still two-dimensional, so you label it like this. What in real life would surface area be useful for? You guys think of something? Why might you want to know how much surface there is? Okay, yeah, I mean, the size of, okay, if you want to paint a building, architecture. Yeah, a lot of, you know, you might want to know for the amount of siding you need to cover the building. Yeah, you don't want to buy a ton of paint that you don't need, right? Or you don't want to buy more siding than you need. So yeah, that kind of thing. Yeah, it could be used to tell you how much surface area is on a planet. We are going to do spheres, like at the end of this week. I'm not sure exactly what the applications of that could be, but yes, it could apply to that. Okay. Does that make sense? Yeah. Okay, we're doing prisms, but we're also doing cylinders because they're kind of in the same family. So basically, the prism formula that we're going to use is two base areas plus the perimeter of the base times the height of the prism. That's what I just did. Two base areas, capital B stands for all of this, the area of all of this, which was 8 times 6 in this case. Perimeter of the base was 8 plus 6 plus 8 plus 6, and H stands for the height of the prism, which is 12. Okay. Now, for a cylinder, it's kind of the same idea. It's got two identical bases. I'll make up some numbers here. And it's got a lateral surface. How do we find the area of a circle? Pi r squared. So one of the circles would be pi r squared. So both of the circles is 2 pi r squared. Now, I'm not going to, unlike the area chapter, I'm not going to make you memorize these formulas. You just have to be able to use them. Okay? So anyway, the two circle areas would be 2 times pi r squared. But how do we find the lateral surface area, all this stuff in the middle? Well, again, if I took the scissors and made a cut, I don't know, do I have a cylinder in here? Not a good one, probably. Like, okay, toss it up here, I guess. Okay, actually, I probably should use a piece of paper. That would work better than this. Okay. Here's my cylinder. If I made a cut on the cylinder and unrolled it, what shape would it make? Rectangle. If I made a cut and unrolled it, it's rectangle. And rectangles are just base times height, right? What's the length of this rectangle? It'd be the same as the circumference of this circle. What's the circumference of a circle? Diameter times pi, or 2r pi. What's the height of this rectangle? It's the same as the height of the cylinder. So, h. The reason I'm using capital H is because I'm talking about the height of the three-dimensional object. Sometimes there's a height inside of a two-dimensional object. Like you could say this is the height of the rectangle down here. And that would be like a lowercase h. the uppercase H would be the height of the prism, the three-dimensional object. Okay, also, you could say the base of this rectangle is 8. That would be a lowercase b. But an uppercase b would stand for the area of the base of the prism. So it would be like all of this. Does that make sense? It's kind of confusing. In a rectangle, like if we have a two-dimensional object, the base of this rectangle is just this. Base times height. But in a three-dimensional object, the base is the entire rectangle. And it has an area. So we use an uppercase b. So the entire rectangle in this prism is the base. Inside the rectangle itself, this 8 is the base of the rectangle. Alright, anyways. So that's the formula for a cylinder. Just kind of plug up. All you have to do is plug in R there, and you plug the height in right there. And voila, you got the surface area. Okay. Those are probably written in your book somewhere, I don't know. See if I can find them. Yeah. Not as well as I wrote them. The way I wrote them is probably a little bit better. Okay, number 1, you guys ready? Write the most specific formula for each. Number 1A is triangle. How do we find the area of a triangle? 1/2 base times height. We also would accept base times height divided by 2. B, how do we find the area of an equilateral triangle? Well, I didn't really give you guys this formula. I think I mentioned it, but it's too hard to remember, I feel like, so I didn't think having you guys, you don't need to have this memorized still. There's a couple times where it comes in handy. There is a trick to finding the height of a equilateral triangle that makes you not need to memorize that formula. Square.
No, S squared.
Right. You could say it's base times height, but the base and height of a square is the same thing, so we just use side squared. Maybe I should be saying A equals. Yes, it's okay. Rhombus. Do you guys remember rhombus?
X times height. Or are we doing the other one?
The one that we used more often was diagonal times diagonal divided by 2, or 1/2 times diagonal times diagonal. Trapezoid.
Base 1 plus base 2.
Divided by 2.
Okay, average of the bases times the height. Instead of base times height, it's average of the bases times height. Was this our January test? You guys trying to remember? I think it was. Pentagon, a regular pentagon. Yeah. You guys don't have to worry about 3 basically, but we do need to kind of remember the formula for regular polygons. 1/2 apothem times perimeter. You might have forgotten what an apothem was, you will be reminded. But for 3, don't worry about A and B, we'll just put 1/2 apothem times perimeter. Okay, number 4. Find the area of a base and the lateral surface area of each figure. Assume the bases are regular. Okay, so we're not finding the total surface area, we're just kind of finding the parts. On number 4, the base is a circle, right? How do we find the area of a circle? Pi r squared. The lateral surface area, we have to go back to my formula. For the lateral surface area of a cylinder, you're going to have to use this, which is basically circumference of the circle times the height. Okay, so those are the two questions. So for the first question, the base area will be pi r squared. For the second question, the lateral area will be 2r pi. Okay, number 5. Okay, how do I find the base area for number 5? What they said in the directions is that these bases are regular, which means all the sides are the same. So basically on number 5, the base is a square. So how do I find the area of that square? 12 times 12, yes. Base times height, in this case they're both 12, so it'd be 144. I'll just put B for base, 144 millimeters squared. Okay, do you guys recall how I said we're going to be finding the lateral area? It's right here. So when I did that problem, I did perimeter of the base times the height of the prism. That'll give us the up and down area. So perimeter of the base times height of the prism. Okay, what is the perimeter of this base? Whoops. Sloppy Joe here. What's the perimeter of this base? What's perimeter mean? Distance around. What's the perimeter of this base? 12 plus 12. 12 times 12 is the area. That's how many squares fit inside. Perimeter is how long is it around the edges. 12 plus 12 plus 12 plus 12. 48.
Oh my gosh.
Okay, times what is the height of this prism? This is 25, it says in the picture. They just told us. Okay, that will give us the lateral surface area. That'll give us how many squares fit on the side. It's a large number. What does that come out to? 1,200. Okay, so we have the base area and the lateral area. When they ask us for the total surface area, we would need the lateral area plus 2 base areas, because there are 2 bases. In this case, they're both squares. So we'd have to do 2 times this plus this. Okay, but on 5, they're not asking us for that. Okay, on number 6, the base is an equilateral triangle. So, how do I find the base area? Well, we kind of did the formula on number 1B, right? For an equilateral triangle. Okay, so you can use that for 6 for the base area. Square root of 3 over 4 times side squared. So the side, S stands for side, so you plug a 4 right there. That means multiply, it's right next to each other. Okay, on 7, starting on 7, we're actually going to have to find the surface area. Find the lateral surface area and the total surface area. Assume 7, 9, and 12 have regular bases. So all the sides are the same. Okay. Let's start with the base area. On number 3, we talked about how do we find the area of a regular polygon. Yeah, 1/2 apothem times perimeter. It's been a while since we used that formula. In this case, the base is a regular pentagon. Okay, what is the apothem? What's the A? What's the apothem of this
3.5.
pentagon? Yeah, it shows it in the picture. They drew this on the bottom, but I'll just draw it right here. It's 3.5 meters. Okay, what does P stand for? Perimeter. What's the perimeter of that pentagon? Yeah, they put a 5 on one of the pentagons, and we know it's a regular, so it's 5 times 5. It's 5, 5, 5, 5, 5. So it'd be 25. Let's go ahead and plug that in. You can, instead of 1/2 right here, you could plug in 0.5. That'd probably be easier. Somebody plug that in the calculator. Or, huh?
43.75.
Okay. So what we just found was the area of the base, one of those pentagons. We also need, and this is one of the questions the book asked for, what is the lateral area? Okay, for the lateral area, we're going to do perimeter of the base times the height of the prism. We already talked about the perimeter of the base right there. It was 25. What's the height of the prism? In the book, they put an 8 right there. The height of the prism is 8. So the lateral surface area is 200. I didn't label these, but all right. This is one of the questions the book asked, so I'm going to circle this or square rectangle it. Now, how do I find the total surface area? We need 2 base areas plus the lateral area. So we need 2 of these plus this. So 2 times 43.75 plus 200. What would that be? 87.5. So 287.5 meters squared. There's a reason we're not doing a lot of problems today. It's kind of beefy. Okay, number 9. Nine is kind of the same thing. It's a hexagonal prism instead of a. Maybe I should do 8 instead of 9. Maybe not. Ugh, what pain. Okay. Let me do a quick sketch. What else we got? 8, 23. this one's kind of a pain. So I'm gonna start off with the base area again. The base area, remember, is 1/2 times apothem times perimeter. The problem on this one is they did not tell us the apothem. So I'm gonna have to use a trick here. If I have a regular pentagon or hexagon, I split it like that. 360 divided by 6 is 60. And then if I draw the apothem in there, that would make this 30. 30, 60, 90. So if this whole thing is 8, this is 4. This will be 4 squared root of 3. You guys kind of remember special triangles? It's alright. I'm not gonna make you guys do that on this test. But the apothem is 4 squared root of 3. The perimeter is 8 times 6. So it's 48. Let's see, what does that come out to? 2 times be 96 square root of 3. Did they leave a square root or a decimal answer? They did both, I guess. I think I'm going to leave the square root answer. If you put the decimal answer, you'd still get it right. Okay. Basically, what was hard about this one is they did not give us the apothem, and I just kind of found it a second ago. It was 4 squared root of 3. So I just plugged that right there. The perimeter is 8 times 6. That's right there. Okay, now we got to do lateral area. How did we find lateral area? Come on, we've done it like 3 or 4 times already. Anybody remember? No, that's the total surface area. The lateral surface area, we did the perimeter of the base times the height. Perimeter of the base times the height. Remember the scissors thing? Cut it, you open it up, you do the perimeter of the base times the height. Okay, the perimeter of the base, we already talked about, 8 times 6, 48. The height of the prism, 23. All right, what's that come out to? 1104. Okay, this is one of the answers they asked for. Okay, how do we find total surface area? You have 2 bases, oops, 2 bases plus all the area in the middle, which we call lateral area. So 2 base areas, so 2 times that, plus the lateral area, which is what we just found. Alright, so this comes out as 192 when you multiply this by 2, square root of 3. And if we don't turn it into a decimal, that's as simple as it gets, because these don't add nicely together. Or you can hit the decimal button on your calculator and turn it to decimal. Okay, let's go look at number 4, I guess, again. I don't know if you guys took notes when I talked about it or not. Okay, the first question is area of the base. So specifically, how are we going to find the area of the base on number 4? Pi r squared. The base is a circle, so you have to find the circle's area. Pi r squared. What is the r? What is the radius for number 4? 7. 14 would be the diameter. It goes all the way across. 7 is the radius. So you'd have to do 7 squared times pi. Remember when we multiplied by pi, most of the time we did not turn it into a decimal. We just left it as part of the answer. If you want to, you can turn it into a decimal. Okay, also on 4, how are we going to find the lateral area? Right, 2 pi r times h. Which basically is the circumference times the height. Yeah, r is still 7. Radius is still 7. H is the height of the cylinder, so that would be the 26. 2 times pi times 7 times 26. Okay, on number 6, how would we find the lateral? We talked about the base area. Hopefully, it's basically the formula from number 1 at B. But how would we find the lateral area? Davin, how are we going to find the lateral area on 6? It's not on the board. I mean, well, number 9's on the board.
Would you find the area of base and area of like the sides?
No. Okay,
4 times 13 times 3.
pretty much, yeah. So it's perimeter of the base. Do you guys, okay, if you guys don't understand the words that I'm saying, this is going to all sound like gobbledygook. Do you guys know what lateral area means? What's lateral mean?
So up and down.
The up and down, exactly. The sides that are not the bases. The up and down sides. How are we going to find their area? This is why I was talking about the scissors thing. If you unroll this, it just makes a big rectangle. The perimeter of the base is like the length of that rectangle. The height of the prism is the height of that rectangle. So it's perimeter of the base is this thing right here. Times height. So on number 6, what's the perimeter of the base?
156.
Perimeter of the base. 4 times 3. Yes. 12. And the height is 13. So you just do 12 times 13. Alright, for number 8, did you guys get the formula written down at the beginning? I probably should have told you, forced you to write it down. Okay. This is a cylinder volume formula. Pi r squared is the area of the base. This would be the lateral area. We just talked about this on number 4. So this is kind of like the two base areas plus the lateral area equals volume. Or sorry, surface area. So this on number 8 is going to give us the answer to the lateral area. And then you'll add 2 circle areas to find the total surface area. Okay, why don't you guys work on those evens to 8 at least. I think we'll do that at the beginning of class tomorrow. Surface areas are kind of the harder part of the chapter. Volumes are kind of the easier part.
Will our test be after spring break?
No, probably next Friday.